questions. Actually, 5 minutes. We've got a minute longer than we had last time. But I don't know if I can do this. Could I just ask that you move in to allow people to take seats in the room? We don't want to overfill the room for safety purposes. We do have an overflow room in SR7 for you as well, which is just across the way. Just an additional note before we start that this presentation will be live streamed, so if you're uncomfortable with the cameras at all, you should leave this presentation now. We'll just wait the next couple of minutes because the overflow room is likely still filling up. Good morning and welcome to UNSW Canberra and our Engineering and Information Technology information session. I'm very pleased to welcome you here this morning. This presentation will be live streamed, so if you're uncomfortable with the cameras, please leave the room. We do have an overflow area over in SR07. My name is Catherine. I'm presenting today in a unique situation. Normally I would present for the School of Engineering and IT. This year, for the first time, we come to you from two new schools. I'm the acting head of school of the School of Systems and Computing, and my colleagues who will join us today are Neda and Ray from the School of Engineering and Technology. We also have some training officers and civilian students who will join us later in the presentation. I'd like to begin by acknowledging the traditional owners of the land, the Ngunnawal people, and the land on which we meet, and their elders past, present and emerging. Our role today is to introduce to you our school, our vision, and the engineering and computer science programs that we present here. Our schools together foster the people who will become Australia's future technology decision makers. So we provide the education for the young men and women who will lead, whether it be in defence, security or civilian industries, our security future. We aspire to create a supportive learning environment that's technology enabled, where we can pass on the skills that they will need to do their jobs in future. The people who come through here form a network who will contribute to Australia's defence and security leadership. We have world-leading educators here, but we also have world-leading researchers, whether it be in their chosen field of artificial intelligence, hypersonics, robotics, civil engineering. Our academics here are leaders in their research field and they're leading educators in their chosen field. We're looking forward to welcoming you here to join our community in one of the engineering or technology disciplines. The presentation today will look across a range of topics. I will first introduce engineering and technology as a field and why you might join this field with us here. We'll then have a look at the lifelong learning opportunities that are available here on our campus. We'll talk primarily about the Bachelor degrees today, but we will mention our postgraduate, our master's degrees and some of our doctoral studies along the way as well. We'll then move on to having a look at our university life, and we'll hear a little bit from our training officers at that point as well. We'll also cover off on some of the key points required for making an application to study here. So why become an engineer? Imagine your future here with a technology degree from UNSW Canberra. Engineers and technology specialists shape the world around us. They build all of the things that we see in our day-to-day life, whether it is from new farming equipment to safer techniques for producing drinking water, to the microchips that we see in the devices around us, or the electric cars that we see on the roads around us. Engineers and computer scientists shape the components of these technologies, and it's their imagination that helps shape our future. From the largest skyscrapers to the smallest of medical devices, if you study here with us, we have a degree program that will help you to contribute to the design of those things that we see around us. And it's not just about the physical environment that we contribute to as engineers and technology specialists, but it's to our health, our safety, and the happiness of the people around us. You might have heard in the past that engineering and technology is about maths and physics, and certainly that is a component of your study. But when you come to university with us and to study a mechanical, civil, aeronautical, electrical, naval architecture, computer science or systems engineering degree, it is preparing you for a career, whether it be in humanitarian fields, aeromedical evacuation, environmental sustainability, engineering, or the sciences, the degrees that we have here provide the foundation for you to do whatever it is that you'd like to do in future. Engineering is not just driven by technical know-how. Our engineered systems interact with people every day, and in order to build them, we need to interact with people and teams. So engineering is about learning the skills to work with teams of people and bring together resources to build the large-scale systems that support our society from day to day. I wanted to ask quickly, who here is interested in computing or cybersecurity as a degree? And who here is interested in engineering as a degree? So the next slides, we'll start by looking at our computer science programs, and then we will move on to looking in depth at the structure of an engineering program. Study here is the start of a lifelong learning journey. The first degree that you typically engage in is a bachelor degree, and the School of Systems and Computing offers two key flavours of program in computing and cybersecurity. The first is our Bachelor of Computing and Cybersecurity with an optional honours year, and the second is the talented student version of the degree, which we call the Chief of Defence Force program. Later in life, you might return and study with us in one of our master's programs. We have Masters of Cybersecurity, Master of Cybersecurity Operations, which is the management flavour of that program. We have Master of Decision Analytics, which starts to bring in some of the artificial intelligence technologies. Master of Systems Engineering, that's looking at project management and end-to-end product development. And then our doctorate programs after that. Computing and cybersecurity itself is a 3-year program at pass level with an optional 4th year of honours study. All of the systems around us integrate computer chips, and if you study this program, you'll have the ability to work with any of those systems. And this is true in both defence and civilian systems. So as part of this program, you will first learn some of the maths and cybersecurity fundamentals that you'll need as the foundation for your further learning. And then you'll move on to some of the technical content in 2nd and 3rd years. Computer science systems aren't just individual systems, they're large systems that can interact with a number of people, and they need to bring together many resources to build them. So some of the subjects that you'll study look at things like systems analysis, where you learn how to analyse the needs of a business so that you can design a system that will meet the needs of the people who work there. You'll also look then at some of the detailed computer technologies, such as data structures, databases, networks, data analysis. And as part of the program, you have the opportunity to do a number of general electives, which help to place your own discipline-specific content within a wider context. As you move into 3rd year, you start to focus in on some of the digital forensics and networks technology. We look at things like web development and security, and you have the opportunity to take discipline-specific electives. As I mentioned earlier, we have expertise here in many areas that are closely related to computer science. Some of our emerging areas are electives in artificial intelligence and robotics and autonomous systems, as well as cybersecurity, that you can fit within either a 3-year program or a 4-year program if you're able to continue into an honours year here. When you study computer science, you are set up to work in any industry that uses computers, which is almost all of them these days. You can take a career in defence within the Army, Air Force and Navy, and many of our modern defence systems incorporate large information systems. As a result, the knowledge that you gain here will be necessary in those industries. Likewise, you can also use the skills here in civilian industries and commercial situations. I'm now pleased to hand over to my colleague Netta, who'll start to have a look at our engineering undergraduate degrees.
Thank you, Catherine. Hello, everyone. My name is Neda. I'm an associate professor in electrical engineering and deputy head of school education for the School of Engineering and Technology. I also would like to take this opportunity to welcome you to this information session and thank you for joining us today. My role today would be to talk to you about the different programs that we offer here at School of Engineering and Technology. We offer a range of undergraduate programs, postgraduate programs, and higher degree by research programs such as PhD programs. Okay, this is a summary slide showing you all the undergraduate programs that we offer here at the School of Engineering and Technology. We offer Bachelor of Engineering honors in Aeronautical Engineering, in Civil Engineering, Electrical Engineering, Mechanical Engineering, Naval Architecture, and also Bachelor of Technology in Aeronautical Engineering. The Bachelor of Honors in Engineering programs are 4-year programs, and the Bachelor of Technology in Aeronautical Engineering is a 3-year program. All of our programs are accredited programs. They are accredited by Engineers Australia, so it means as soon as you graduate, you can start working as a qualified engineer, and you're an accredited engineer to start work in Australia and many other parts of the world. We also offer postgraduate education. Postgraduate education is usually the subsequent or second degree that people might do at the university. They might do it just to skill up in their career, or they might want to have a change of career, or just prepare for a research degree, which is usually a Doctor of Philosophy program. In the School of Engineering and Technology, these are the postgraduate programs that we offer: Master of Capability Management, Master of Space Operations, Master of Space Engineering, Master of Project Management, Master of Explosive Ordnance, and PhD program, Doctor of Philosophy and Professional Doctorate programs. My main focus today is going to be on the graduate program, and I'll just tell you a little bit about our undergraduate programs in general, and then talk about each one of the individual programs that we offer here at School of Engineering and Technology. So our Bachelor of Engineering honors programs, as I mentioned, are 4-year programs. Bachelor of Technology in Aeronautical Engineering program is a 3-year program. UNSW academic calendar is 2 semesters plus optional summer. We offer a limited number of courses over summer, and that's usually for a student who might need to catch up, or they might be following a non-standard program. All courses are measured in units of credit. All of the engineering courses are 6 units of credit courses. A full-time typical student profile is basically 4 courses per semester. So 4 6 units of credit courses per semester, that comes up to 24 units of credit. And the normal, in terms of the workload expectation, the normal workload expectation for each one of these courses is around 150 hours per semester. So doing 4 courses is about 600 hours in class and outside class work during the semester, which is about 15 weeks. So if you do the calculation, if you do the math, it's about 35 to 40 hours of work. So it's basically full-time study. The way that it's sort of broken up in most cases is that you'll be in class for 4 or 5 hours per day, and then you need to do self-study for another 3-4 hours, just going through the material, doing your homework, writing lab reports, and preparing for assessments. Okay, so I just have an example here. This is the mechanical engineering program. I just want to talk to you a little bit about the structure of our engineering honors programs. So as I mentioned, these are 4-year programs. As you can see, year 1, year 2, year 3, year 4 here on the left-hand side. And then we have semester 1 and semester 2, and I'm showing you which courses students will be doing during semesters. Semester 1 is February to June. Semester 2 is July to November. And engineering programs have typically got a very structured curriculum. So the first year of the program is mainly the foundational knowledge courses, so basically engineering maths and engineering physics courses, intro to programming, introduction to programming courses, and computational problem solving courses. So they provide you with the base that you would need for your subsequent engineering core courses in the specific discipline that you'll be doing your degree in. So in terms of the core of the engineering program, depending on the degree that you're in, you will be doing a different set of courses. I've got the mechanical engineering here as an example. The blue courses are the core of the mechanical engineering courses. They start in the first semester of first year with Introduction to Mechanical Engineering, then Engineering Mechanics in the second semester, then in the second year is Thermofluids, Fluid Mechanics, Mechanics of Solids, Mechanics of Machines, third year, Vibration and Control, Engineering Materials, Engineering Structures, System Engineering and Project Management course, Heat Transfer and Refrigeration, and then followed in the fourth year Biomechanical Design 1 and 2, and some technical elective courses. And you also be doing some general education courses. So as Catherine mentioned, the general education courses are basically the courses designed to just broaden your knowledge in general. The technical elective courses are designed to let you specialize in your area of interest. So from a range of courses, you can choose the course that you're interested in or is relevant or useful for your future career goals. So within the core of the engineering program, we have some project and design courses. They're still the core of the engineering program, but I've shown them with a different color because they're sort of more hands-on, more open-ended courses. Students will be asked to do an engineering project. Sometimes there'll be components that they have to do individually, and there might be components that they do as a group with other team members. And these are designed to basically help a student develop problem-solving, critical thinking skills, and be just to practice, to apply the knowledge that they have gained throughout the degree in implementing or completing a project, a small engineering project. All of our engineering programs are engineering honors programs. So basically there is an honors component, which is basically a capstone project in the final year of a study, spread over like 2 semesters, so it's a year-long project. A student will be doing a significant project under the supervision of an academic, and they will be basically showcasing their problem-solving, critical thinking, and leadership and application of the knowledge that they've gained throughout the degree in completing a significant engineering project. As part of the engineering programs, all of the engineering honors program that we offer, students are required to complete 60 days of engineering work experience to gain practical experience, practical engineering experience in the workplace during their degree. This is a requirement of Engineers Australia, and all of the students who complete a Bachelor of Honours in Engineering, they need to complete these 60 days. For a student who will be doing a Bachelor of Technology in Aeronautical Engineering, which is a 3-year program, this 60 days is reduced to 40 days, so it's a bit shorter. Okay, so now let's talk about mechanical engineering. What's mechanical engineering about? So mechanical engineering is about machines. It's about designing, manufacturing, maintaining, and improving machines that we use in our everyday lives. These machines can be as simple as a lawnmower or a hedge trimmer, or can be something more complex like a robot, spacecraft, or can be something that's used in defense, for example, a tank or a weapon system. It's a 4-year program, and students who graduate with a mechanical engineering degree, there's a whole range of opportunities available to them. Obviously one pathway is working in defense, and also defense industries, commercial, consultancies, manufacturing, aviation, automotive, mining industry, aerospace, and energy, to name a few, are some of the sectors they can work in. Just back to that structure that we had a couple of slides ago, they're just showing you the structure of the mechanical engineering, so I'm not going to go through this again, so just already talked to this program. So the next program that I would like to introduce is the Naval Architecture program. So it's a Bachelor of Engineering Honours in Naval Architecture. This is our newest program at School of Engineering and Technology. This is again a 4-year program. The first 2 years of this program runs in parallel with mechanical engineering. So students can either join in Naval Architecture from the beginning, from year 1, or in year 3 after completing 2 years of mechanical engineering and also aeronautical engineering. This program is also about machines, designing machines, but this time machines that go in or on the water. So it's about designing boats, ships, submarines, or in general marine vehicles. So in terms of the industries, naval architectures can work in. Again, lots of opportunities are available in different industries and different sectors: defense industries, consultancies, ship and boat building, and repair companies and regulatory authorities, to name a few, are some of the sectors and organizations they can end up working in. This is the structure of the Naval Architecture program. The first 2 years of the program run in parallel with mechanical engineering, so basically the exact same courses. The program starts to specialize in the 3rd and 4th year. In the 3rd year, students will be doing courses like Naval Architecture practice, ship structures, hydrodynamics of ships, design of ships, and then in the 4th year, they will be doing ship propulsion and marine engineering, ship design, project 1, or project A and project B. And as you can see, they basically just be following the same structure, that they will have options to do some technical electives, and they'll be doing an honors thesis as well in the 4th year. Same 60 days of engineering work experience. So that applies to all of the engineering honors programs that we offer. The next program is Aeronautical Engineering. It's again a 4-year program. So it's again about machines, but this time the machines that can fly. So there are lots of common courses between mechanical engineering, naval architecture, and aeronautical engineering. The program, these programs start to specialize in the 3rd and 4th year. So aeronautical engineering is about designing, building, maintaining, and manufacturing airplanes, helicopters, UAVs, and wind turbines. In terms of the industries you can work in, defense industries, space industries, airlines, civilian and military aerospace organization, to name a few, are some of the places you can end up working in. The structure of the program. Okay, so most of the courses in the 1st and 2nd year are pretty much the same as the mechanical engineering, but we have a specialized course in the 2nd year here. It's called Fundamentals of Flight. The program starts to specialize in the 3rd and 4th year with aerodynamics, engineer structure, flight dynamics, aircraft control, applied thermodynamics and propulsion, aircraft and system design 1 and 2 in the 4th year. A few technical electives that you can choose from, like a range of options that are going to be available to you, like rotorcraft engineering, hypersonics, instrumentation, some other courses that you can do, and then the honors thesis in the final year, again, similar to the other engineering programs. We also offer the Bachelor of Technology in Aeronautical Engineering. So this is a 3-year program. The first 3 years of this is pretty much the same as this program, but just consider the first 3 years. Okay, so it's a 3-year program, very aligned with the Bachelor of Engineering honors in Aeronautical Engineering in the first 3 years of the program. So this is mainly designed for those intending to become air crew, including pilots, and those who want a solid knowledge in science and engineering. The engineering work experience requirement for this program is 40 days instead of 60 days. Okay, so the next program that we offer is the Bachelor of Engineering Honors in Electrical Engineering. So this program is about designing, building, maintaining, and manufacturing electrical or computational systems, electronic system, power, and telecommunication systems. Again, a broad range of sectors and industry you can work in with an electrical engineering degree, such as defense industries, consultancies, government, and small or large private industrial groups, telecommunications companies, power, energy sector, electricity authorities, renewable energy generators, to just name a few of these places. This is the structure of the electrical engineering program. So in the first year, in addition to those foundational knowledge courses like engineering math and engineering physics courses, you'll be doing introduction to electrical engineering, electrical circuits courses. In the second year, again, you'll be doing maths, lots of maths and physics and analog electronics, digital electronics, microcontrollers, a design course, electrical engineering design project 1. And then in the third year, signals and system engineering, electromagnetics, power machines, signal processing, control, communication systems, and electrical engineering design projects is just some of the courses you'll be doing. The structure is pretty much the same in the fourth year, but you have options of technical electives to choose from, such as satellite communication, radar techniques and application, smart grid, renewable energy. You can do courses in AI. You can do space courses. Satellite communications, just one of them. Orbital mechanics, space situational awareness. So lots of options are available in terms of the technical electives that you can choose from depending on your area of interest or your career goals. Okay, the last program, but not the least, I would like to introduce today is the civil engineering program. Again, this is a 4-year program, so it's about planning, designing, constructing, managing and maintaining structures and infrastructures, such as buildings, roads, bridges, water supply systems, and transportation networks. In terms of industries, civil engineering graduates can work in defense, government organizations, construction, large public and specialist consulting companies, to name a few or some of them. Okay, so this is showing you the structure of the civil engineering program. So we have civil engineering specialized courses from year 1, Introduction to Civil Engineering, Engineering Mechanics, year 2, Civil Engineering Materials, Hydraulic Engineering, Soil Mechanics and Geotechnical Design, Structural Analysis, Transport Engineering, Environmental Engineering, Design of Steel and Timber, Design of Concrete, Foundation, Pavement Engineering, Hydrology, just some of the specialized civil engineering courses. So again, same structure applies. There will be a thesis, there will be work experience the student need to complete. Okay, so I want to talk a little bit about that honors component. So that's basically what you might have heard people refer to as the honors thesis. That's basically what students do in the final year of the engineering programs. They complete a significant engineering project that's spread over basically 2 semesters, so it's a year-long project. And students can basically choose topics of their interest in their area of engineering discipline and work one-on-one with academics to complete their project. And basically they can showcase their problem solving and critical thinking, leadership, and application of the knowledge that they've gained throughout their degree in completing that project. So we have a broad range of state-of-the-art facilities and internationally known researchers in the School of Engineering and Technology, and these are some of the areas that our students are currently doing their thesis in. So hypersonics, hydraulic, thermofluids, advanced structure, infrastructure, impact dynamic, composites, AI, system engineering, optimization, robotics, photonics, quantum. You can see the range. It's just some of them. Actually, I didn't really list everything, but you see that our students are doing a broad range of different projects, very interesting, very relevant projects to their engineering discipline. And this is basically at the end of their studies, they can basically wrap up and apply whatever they've learned throughout the degree in completing this significant engineering project. Okay, I think I now hand over to our head of school, Professor Ray. Ray is going to talk to you about the university life.
Thanks, Neda. Thanks, Catherine, and welcome once again to everyone. I'm sure you would have been going through quite heavy stuff in terms of teaching, so I've taken up the easy bits, which is more important from the student's point of view. And what I'm going to talk about is pretty much about university life. I'm sure everybody is on top of how many courses you need to do, how many credits and whatnot, maths, physics. That's a scary bit. So let's move on to the easy bits. What do I get as a student? I would say the most important thing that you should be looking at is free food, discounted tickets, for movie tickets, I mean. There are some ski trips, which is pretty much organized by ARC, and ARC is a UNSW student organization, and we do have a setup in here. So make the most use of that while you are here. Now, the next thing, apart from the more structured engineering stuff and the computing stuff that you have heard, what else is up there? Obviously, the students actively engage in a number of activities or projects, as you may call it. One of them relates to UAV challenge, which typically used to happen and was quite effective at some point of time. And we do have quite an extensive UAV group, which basically is involved in designing from big ones to small ones. If you are not really interested in going up in the sky and gliding, you think something at a faster speed would be good, then you might join the rocket team. I must tell you that this is a fairly new addition in our school. I think it's about 2 years or so, is my best guess. That is yet an opportunity in the event you are interested in moving up in the air at a fairly high speed. Now, if you come back and say, well, not interested in anything up in the air, I'm more interested in driving a car, then the next one is for you. And you would have seen the academy racing setup somewhere in the green over here. This is basically a competition held across various universities, and UNSW Canberra indeed has a team where they build such cars pretty much every year, and it is a competition held across other universities. So you take this vehicle up there and show its performance. If you are a winner, of course, you can brag all about it. The next thing, which appears to be interesting, I mean, just looking at the picture, is somebody playing video games. I must tell you that partly yes. I mean, of course, the computing people won't like me saying that. But it is basically sort of a gaming in a real-life setting. So that might be quite daunting as well. Now, the next question, I'm sure many of you don't need to ask yourself. You know pretty much where the answers are going to come from. Either your parents have told you, or you had brothers and sisters, or anybody that you know who have been into UNSW Canberra. And that could be one of the reasons why you are considering a career in UNSW Canberra. Now, a couple of things just to let you know, in the event somebody is interested in the numbers. UNSW as such is a fairly large university. It has got well over 65,000 students. And of course, over the years, it has a significant alumni base as well, which is basically helpful in your networking. You're also aware that it has got multiple campuses, and of course, Canberra is just one of them. And UNSW in Canberra has been in existence for over 50 years. And of course, Catherine has talked about our mission in terms of educating the engineers. Many of them end up in defense. Some of them end up in consulting. Some of them might be going to normal civilian roles in any of the engineering companies, in most cases. Now, the other thing which is also interesting is somebody is really interested in numbers. I mean, of course, you have to associate some amount of faith in those kind of numbers. Currently, UNSW is under 20, which is number 19. Sounds good. And we are the second in Australia. One of the most important things which I would say, which UNSW Canberra has, is basically fantastic student-to-staff ratios. And this is something which is unparalleled in any other setup that you may ever think about. I mean, think about the bigger universities. It is next to impossible to match this ratio. What does it give you? Pretty daunting setup for the students, because I teach mechanical engineering. It's a class of about 25. I know each and every student by the name. Okay? So it's not different that if somebody goes missing, I will definitely pick up. It also means the student has got significant amount of access in the event they want to talk to any of us. The elect program would have about 50 odd students, but again, this kind of ratio definitely helps the students to interact with the staff in a much more easier setting, I would say. Now, this is a snapshot of how the campus looks like. You can see the fancy green up there. Indeed, a very interesting place. You're not supposed to walk on it, other than military actions or parades or whatever they might have. On the left of that is basically the accommodation that you get to see, where the defense students are typically placed. On the right-hand side is the academic side of things. That's where the lecture theaters are, that's where the staff offices are, that's where the labs, and so on. So this is a clear view of the campus, and of course, everybody is aware of Telstra Tower, if you have been in Canberra long enough. And if you're wondering how far is Sydney, it's about 3 hours drive. I'm sure many of you might have traveled from there. I don't think we need to go through this a bit much, but I'm sure everybody is aware as to why you would like to consider UNSW Canberra in the event you are talking about a career in engineering or computing. Now, I'll just touch upon a few things related to the admission process, but again, I will guide you through the process very briefly, but I'll give you the pointers to get in touch with Defense Force recruiting in the event you are planning to take up these undergraduate study through the services, or you may say, look, I'm not interested in that, I just want to go in as a civilian, in which case, talk to Student Administration Services, and they will take you through. This is a very, very simple snapshot of what really happens in the event you are talking about defense applications, which effectively means you are basically joining one of the services. It's a two tracks. The first is basically application through Defense Force recruiting. This happens typically in year 11. And the one at the bottom is basically the normal university admission process, which happens in year 12. So if you are really thinking about a career via defense pathway, the best point of contact would be to get in touch with Defense Force recruiting, know what their limits are, because they would have a certain set of requirements and the processes to move through. If you want to know about the ATA requirements, the selection rank, etc., talk to SAS, and they'll definitely guide you through what is required if you want to pursue this as a civilian, which pretty much is this. And this is exactly the same line of action that you would expect to undertake if you are applying for any other universities. Means basically this process. Now, one of the other things which we are extremely proud about, we do run an event which is referred as Young Women in Engineering. It has been there for quite a while, where the students basically from year 9 to year 12 come and spend 3 days in this campus, where they are basically given an exposure in terms of what engineering is like, do fun projects supervised by quite a number of very passionate colleagues. So they get a sense of what is it that the engineers do. Many of the students wouldn't have much of a clue, but this experience definitely has been extremely valuable, and we are getting to see more and more students who have participated in this program visible in year 1 cohort. So that's a great message and something that we are definitely proud about. The exact dates of this for 2024 is not finalized as yet, but look out for the dates. Now, at this point in time, it is also important for me to hand it over to the students who are there, who are both the civilians and the defense students, and they are in the best position to talk about what on earth goes on in a day. Okay? It's not for me to talk about it, but I'll hand it over to them to talk about from waking up How do they survive? What goes on till end of the day? So for some might be 6, some might be 4, and you can definitely hear from them.
Yeah, okay. Well, I might just run through my basic day. So as military, so I do Naval Architecture Engineering. I did my first 2 years as a mechanical engineer, and I spent a year before I came to ADFA doing my officer training and work experience in the Navy. So my typical day, I will usually have roll call at 7, so nice early wake up. Our military hours are 8 to 10 in the mornings every day, or every weekday anyway, and that'll be something like PT, that'll be doing military lectures, all the sort of military education you can be expected to take away from ADFA. Then from 10 to about 4 p.m, maybe later for engineering, you'll be doing your engineering classes. That's when all your contact hours will be, usually. That's when you'll be doing your lectures, your labs, everything. Then some days in the afternoons during your school week, you might have PT in the afternoon, you might have some more military lectures, having some VIPs come talk to the university or the ADFA cadets. And then your weekends are usually very free. Sometimes you might have something like ADFA Open Day to come into work and do that. But usually that's most of your days of the week. It'll change day to day, but that's the overview. And you have time for sport and your extracurriculars afterwards. ADFA encourages you to do at least one sport. They will pay for that. And the rest of it is just studying. Yeah.
I'm just going to introduce myself first. So my name's Scarlett. I joined in the beginning of 2020, graduated 2019. Similar to Lauren here, I'm also studying naval architecture. We're going to try and promote and get as many of you as we can because it's an awesome course at the moment. We're both in our 3rd years at the moment, going to go into 4th year next year. But I'll pass it along, and then if you have any questions, we'll stand on the floor and answer them.
I'm Harrison, so I'm a 4th year electrical engineer. So for engineering, you graduate ADFA at the end of your 3rd year and you come back and do your honours year. So I'm currently going through and doing my thesis, and I'm happy to take any questions about the whole electrical engineering program, day-to-day life at ADFA, and kind of how that works as well after you finish your 3 years and then come back for your 4th.
Hey, my name's Flynn. I'm a 3rd year RAF ELEC. My day is pretty similar to the other 3rd years. We all wake up at about 7, have our military lectures in the morning. Then from about 10 till 4, we have our university lectures. Usually with engineering, most of my days run till 6, which is a bit difficult at times. But it's something you just get used to, and I still have plenty of time in the afternoon to pursue like any extracurriculars I want. So last semester, I still had plenty of time to go and pursue a research project with a Formula SAE team, which was quite engaging and helped a lot with my electrical engineering degree.
Hello, my name is Curtis, and I'm a civilian. So my day is very different compared to the people in the military. So first of all, I don't have roll call, I don't have PT, and basically, just like other university students around Australia, there's no obligation to attend lectures, but you should probably attend lectures. But as a civilian, your day, saying that this university is like any normal university is a very heavy understatement, because not a lot of places not a lot of universities in Australia where you get to learn alongside people in uniform. Also, my day starts usually at around 10, and I end at 5, which is pretty good. And on days which there are military training days, it's a holiday for civilians. So it's pretty good. But thank you.
Thank you very much. Look, I'd like to open for questions, so please raise your hand and direct your question. Green jacket. Yeah. What kind of extracurricular activities do you have? The question was, what kind of extracurricular activities do we have here?
I think the answer is, what don't you have? So as long as a student is willing to like take it up and head it, then you can sort of choose your own adventure. Like, I don't know how many sports we have. Like, we have so many other things. So there could be the DJ VEC. Yeah.
Yeah, so even as an engineer, I'm the head of the adventure training VEC, which I don't know if any of you've seen us doing some of the abseiling and stuff, but that's all of us. So it says up there about 3 to 4 hours of self-study at home. You're looking, if you're paying attention in your classes, more like 2 hours. So it gives you heaps of time to do your actual extracurriculars. So I used to do some soccer, I'm in AT, I do social volleyball, and I still manage all of that with engineering. So there's a lot of options for you. With the university, I believe there also are some ARC-led projects, but I'm not too sure about them.
Yeah, they basically have everything. They used to have a Quidditch team. You know, whatever you want to do, basically Defence will help you do it. So a lot of people actually play civilian competitive sport or play it at a state or national level. Defence will often fund and help you go to that. So we have some people that are currently trying for the women's rugby teams. So Defence will help and sponsor you to do that. For me personally, I'm involved in the jazz band after hours as well as volleyball. So you've got a lot of time to do a lot of things, and Defence is often really supportive of doing that after hours as well.
Yeah, same goes. I still have plenty of time after hours to do what I want to do. So I'm in the jazz band with Harrison. I had enough time last semester as well to be in the performing arts company. So that was pretty intensive. So that was about 4 to 5 hours of rehearsal per week. But even with that, I still managed to fit everything in. So you shouldn't be worried if you're doing an electrical engineering degree that you won't be able to do anything else you want to do. Like, I still do soccer, I still play music, and all of that stuff.
Another question?
In your fourth year, how does that change your structure throughout the day? It's different, or is it all the same?
The question was, how does your structure of your program change in fourth year?
So once you graduate ADFA, you kind of have two avenues. You can either step into a support role for first years, which is what I've done, or you can step into the advanced squadron. So there's a separate squadron for all of the advanced students that come through the academy, and they're all managed just under that. And what that looks like is you don't have your military commitments from 8 till 10. The only thing you do have is PT on a Wednesday morning. But other than that, you are here to study, and that is about it. So it relaxes a bit. You've no longer got the commitment of the military program because that's tailored around a 3-year degree for the arts and business students that then graduate. So you graduate ADFA. For me, I promoted when I graduated, and then I come back and continue studying. So it's a lot more relaxed in your fourth year, and you've got a lot more time to kind of work on your open-ended projects, so your thesis.
Question down the front.
Is there any chance that this year will change the 3-semester model that UNSW Sydney has?
At the moment, it's unlikely that this part of the university will change to the term model. So the defence component of the university will remain on the 2-session model. You might have heard of our new campus, our city campus that's opening up with the School of Professional Studies. And that campus is a non-defence campus, and that may well take the term structure. But here we will retain the semester structure.
When do you get holidays and how much holidays?
Question was, when do you get holidays and how much holidays?
So if you're joining the military, whilst you're at ADFA, is the most amount of holidays and leave that you will get in your career. So they always tell us to utilise that as much as we can. So if you don't have SSTs, which is your single service training in Navy, Army or Air Force, you get your holidays. So typically we'll have around 2 weeks in Easter time, 3 weeks in the middle of the year, 2 weeks around September-ish period, and then you get about 2 months off at the end of the year if you're not doing single service training. And then for us engineers, we typically conduct our work experience in that period as well for just over a month. So we get quite a lot of leave, which is quite good.
talk about funded flights as well.
Oh, yeah. So a perk of defence as well is if you are from an outer location but you're living in Canberra, you get 3 funded flights to go visit your next of kin, so your family, back home. So you don't have to take it out of pocket in the holidays to go see your family. Defence will pay for it. So it's definitely a perk.
On the civilian side, military training days are holidays. And when you go on holidays, there's no training whatsoever. Yeah, it's just normal holidays for civilians.
Yes. The question was whether there is military assessment alongside the academic assessment.
Each semester, while you're doing your military training, you might have like an essay to write or something. You have to pass your fitness tests, but it's nowhere to the extent of your academics, and they will usually give you time during your military hours to complete those. I don't know many people who haven't been able to pass them. So it's more just to confirm that you are like listening to the lectures and taking stuff in.
Yes. I can partly answer. So we have an interesting situation at the moment. Normally we have a majority of our defence students living over on that side of campus. At the moment we are actually having some building work over there, and we have some of our students living off campus over at UC, and Defence is providing buses for them to move between the 2 locations. Our advanced students do not need to live on campus, so they have other accommodation options as well. Anything else?
Yeah. So generally ADFA is a live-in course, so everyone's expected to live in for the duration of the course of 3 years. At the moment, as has been mentioned, there's some building work, so they've arranged alternate accommodation just while that's being sorted. But they're hoping to have that finished by the end of this year, so that next year moving forward, it will be a full living course. You'll live over in the lines that you might have had a tour of, and eat in the mess as well. For us 4th years, we have the ability to go and find our own apartments and live off. You can do share houses with mates or live by yourself or with partners, and that gives you a bit more flexibility, and you drive into work each day.
Yes.
Navy has the 1 year before ADFA. Does that mean you have one less year return of service, or is it still the amount of degrees plus kind of years degrees?
The question was around return of service for Navy.
Yep, so that 1 year for an engineering degree, when you sign up for 9 years, that is one of your 9 years. So you only have to pay back 4 years after you finish your degree.
Yes. So the question was around whether there is an option not to do the honours. It does depend which program you're enrolled in. So if you're doing a Bachelor of Computing and Cybersecurity, for example, you can graduate after 3 years. Or some defence students, a small number of defence students, have the opportunity to come back and do an honours year. If you're an aeronautical technology student, a BTEC student in aero, then it's a 3-year program. Some students do then decide that they want to move into the Bachelor of Engineering and do that 4th year. For all of the other engineering programs, it is a 4-year program, and the honours year is not optional.
Does UNSW have accommodation for civilian students?
No, UNSW does not have accommodation for civilians at this stage.
Just with the Yowie course, when the girls come, do they live at the accommodation here, or do they find their accommodation?
So the question was about our Yowie program. The Yowie program is a 3 day non-residential program. Most of the girls who attend are from Canberra or the surrounding regions. We have had a couple from interstate, and they'll often come with their parents who'll stay in a hotel for a couple of days just to be with them. Yeah.
You mentioned the BTEC students would take the fourth year. Would they then graduate with an engineering degree?
That's correct, yeah. So the question was that the BTEC, if the students take a fourth year, will they have an engineering degree afterwards? Yes. Yeah. I believe that's decided beforehand. Can you guys comment?
Yeah, so regarding being a pilot and studying engineering, so I've got one of my friends who's currently doing fourth year Aeronautical Engineering. Basically, he went in and did a Bachelor of Technology and then asked Air Force to do that fourth year because he was basically going to be waiting for flight training school. So he had that extra year and Air Force were happy to let him continue doing his degree. Generally, they'll only let you in to do the Bachelor of Technology, but they will make exceptions and allow you to continue your studies and make that into a full engineering degree.
Thanks. With no further questions, I'll close the session. Thank you very much.